Hello everyone and welcome to Module 9, Advanced SQL Features, Procedures, Triggers and Security. So far in this course, you have learned how to query, combine, analyze, design, and optimize databases. Now it is time to make your databases smarter and safer by adding logic directly inside the database and protecting it properly. We will cover stored procedures, triggers, and security, features that turn SQL from a simple query tool into a full professional application layer. Let's get started. In this module, you will learn why stored procedures and triggers are essential for professional databases. You will learn how to create, use, modify, and delete stored procedures. You will learn how to work with parameters in stored procedures. You will learn what SQL triggers are and how they automate actions. We will look into different types of triggers, using triggers for data validation and business use. Core database security concepts, user authentication, and role-based access control. You will learn data encryption and audit logging. You will look into practical applications and best practices for secure automated databases. You have already learned how to query, manipulate, design, and optimize databases. Now we move to the next level, making databases smarter by adding logic directly inside them using stored procedures and triggers, and making them safer through proper security. These features reduce the amount of code you need in your application, enforce business rules consistently, and protect sensitive data. Procedures, triggers, and security turn a good database into a great, trustworthy, production-ready system. Stored procedures. First, let's talk about stored procedures. What is a procedure? A stored procedure is a named reusable block of SQL code that is stored inside the database like a function you can call by name. Here is the basic example. Create procedure, get customers order. Begin with select order ID, order date. Sum as total from orders and join orders item on order ID. Join product with product ID, where customer ID and group by order, then end. What are the benefits of those stored procedures? The benefits include centralizing business logic, reducing network traffic, better performance, the procedure is preprofiled, enforcing consistency across different applications, easier security you can grant, execute permissions on the procedure instead of giving direct access to tables. Stored procedures with parameters. Stored procedures became even more powerful when you use parameters. There are three types: in, input only; out, returns a value; in, out, both input and output. Here is an example. Create procedure get customer total in customer ID out total spend. You begin with select sum into total spent from orders. You join order items on order ID. Join products on product ID, where customer ID is customer ID. Then you end. To call it, use call guest customer total bracket 101 comma total and select total. Modifying and deleting stored procedures. To modify a procedure, the most common and safest way is to drop and recreate it. SQL drop procedure if it exists. Get customers. Create procedure, get customer, and begin new version here. End. Best practice. When working in production, use version names or migration tools to manage changes safely. SQL triggers. Next are triggers, which are very powerful for automation. A trigger is a stored program that automatically runs when a table is modified, either insert, update, or delete. Triggers can run before the action, so you can modify the incoming data or after the action. And the common uses are triggers enforces business rules, e.g., prevent negative stock. Triggers automatically audit changes, and triggers update related tables, e.g., reduce stock when an order is placed. Triggers validate date before it is set. Types of triggers. Triggers are defined by timing and event. Before insert, after insert, before update, after update, before delete, after delete. There is a practical example that prevents selling more than available stock. Create trigger check stock before order. Before insert on order items, for each row, you begin declare current stock, then select stock into current stock from product, where ID is new product. If current stock is before new quantity, then signal SQL state to 4,000, 45,000. Then set message text insufficient stock for this product. And if end. Trigger for data validation and auditing. Triggers are excellent for validation. Example, prevent salary decrease. Use this query to prevent salary decrease. Create trigger, validate salary update. Before update on employees for each role begin, if new salary is less than all salary, then signal SQL state to 45,000. Then set message text to salary cannot be increased. End if end. For auditing, you can log every change as it is in this page. Create table audit log. Int auto increment preliminary key, table name, action, old value, new value, change by, and change at. Then create trigger to audit employee update. After update on employees for each role, begin insert into audit log, table name, action, old value, new value, change by values as employees, update, old, new, and user. Database security concept. Now let's move to security core concept goals. The security core concept goals are authentication, which means to verify who are you. Authorization, what are you allowed to do? Confidentiality, protect sensitive data. Integrity, to prevent unauthorized changes. And auditability, to track who did what and when. Common threats include SQL injection, excessive privileges, unencrypted data at rest or transit, weak threshold, insider threats, user authentication and role-based access control. First, user. To create user, create user analyst at local host, identify by, then select strong password. Role-based access, best practice. The best practice is to use role-based access using this query. Create read-only role. Grant select on school underscore DB as the database you want to give access to. Grant read-only role to the user you have created. Then set default role to read-only role to the user you have created. Always follow the least privilege rule. Never use the root user for applications. Data encryption and audit logging. For sensitive data, use encryption. When data is at rest, transparent data encryption. MySQL Enterprise and SQL Server transparent data encryption, while data in transit requires SSL and TSL connections. MySQL example, the query is alter user app underscore user at localhost require SSL. For audit login, enable the slow query log or use audit logins. You can also create custom login with triggers as we saw earlier. Always encrypt highly sensitive columns like passwords or credit card numbers at the application level or using built-in functions. Practical applications. Let's look at some real-world examples. Order processing procedure. Let's look at this query that says, create procedure that processes order in customer ID, product ID, and quantity. Begin, start transaction to check the stock trigger first automatically. Then insert into orders customer ID. Insert into order items, order ID, product ID, and quantity. Then lastly, insert ID, product ID, and commit. Audit trail trigger automatically logs every salary changes for compliance. Other real-world examples. Reporting role. Analysts can only select from views, never directly from base tables. Best practices. Here are the key best practices. Use stored procedures for complex business logic. Keep triggers small and fast. Avoid heavy queries inside them through thoroughly test procedures and triggers because they run automatically. Use roles instead of granting privileges directly to users. Never store plain text password. Always use proper hashtags. Require SSL for remote connections. Limit root user usage. Create dedicated application users. Regularly review audit logs and user privileges. Document all procedures, triggers, and security policies. Always follow the least privilege principle. Excellent work. In conclusion, this module has taught you how to make databases smarter with stored procedures and triggers and safer with proper security features. You now know how to create reusable logic and post rules, automatically audit changes, control access, and protect sensitive data. Skills that are required for any production system. These features are used daily in enterprise applications. In the final module, we will cover career development, professional practices, and portfolio creations. See you in the final module.